Yes, I had the AI prepare 10 more questions for you about the sum and difference of two cubes. These are a bit more challenging than the first 10 questions I had prepared on this topic. The previous ones were a bit easier. If you haven't solved the previous 10 and would like to, I'll leave them in the description section as well. Be sure to try solving the questions on your own before watching me solve them. Again, the first link in the description section is the link to join our school community, and the second link is to the lesson where you can find a clean and solved PDF of this document. So let's get started with our first question. It says, factorize x to the power of 6 minus 1. First, let's recall once again. The expansion of x cubed minus y cubed is x minus y times x squared plus xy plus y squared. When the sign in between is plus, this part is plus and this part is minus. This part doesn't change. If we're going to solve it using the difference of two cubes like this, let's proceed as follows. Let's see it as the cube of x squared minus the cube of 1. First minus second. The square of the first plus the product of the first and the second plus the square of the second. From here, we'll factor x squared minus 1 as x minus 1 times x plus 1. The x to the fourth plus x squared plus 1 in the back remains as it is. So what can we do about this? Actually, this alone is a very nice question in factoring. I'm just solving this. I'll add it here afterwards. It's a really good question. I'll prepare a separate document for you about x to the fourth just about this and similar types of questions. Plus x squared plus 1. Now, we'll ask ourselves, from the square of which expression do we get this and this? And we'll say it comes from the square of x squared minus 1, or from plus 1. We'll see in a moment why we need to take the negative, or we'll see why we need to take the positive. We'll decide on that now. What do we get when we expand this? We get x to the fourth minus 2, x squared plus 1. Do we have minus 2x squared? No, we don't. Then, if we put a minus 2x squared here, we also have to add a plus 2x squared. Now, in this way, we have factored x to the fourth minus 2, x squared plus 1. We've grouped it. What do we have left? From the x squared plus 2x squared shown in green, we get 3x squared. But the fact that this part is positive prevents us from factoring this expression as a difference of squares in the next step. That's why this part should be positive, not negative. Let me erase these right away. If this part is positive, the expansion gives us x to the fourth plus 2x squared plus 1. I'll erase these parts as well, and I'll erase these too. So do we have this? We have x to the fourth, we have 1, but 2x squared. We don't have the 2x squared here. So if we add plus x squared and minus x squared here, does the sum of these give us the green 2x squared here? Yes, it does. What increased? Only this increased. Minus x squared. Now here we can use the difference of squares. First minus second. First plus second. So we'll go ahead and write this in place of the yellow part here. In other words, this is the answer for the yellow part. This is the answer for the yellow part. And at the front, we had these two. That is, we had x minus 1 and x plus 1. So this will be our answer. They got really cramped over there. I'm not very happy about it. That's why I'm writing it out. X minus 1, x plus 1, x squared minus x plus 1, and x squared plus x plus 1. For those who say this question can be solved in another way, yes, we could have seen this as x cubed minus the square of x cubed minus the square of 1. So at first, instead of seeing it as the difference of two cubes, we could have seen it as the difference of two squares. Then, the first minus the second. We would have said the first plus the second. We would have expanded this and that within themselves. Let's expand them. X minus 1, x squared plus x plus 1, and the other one, x plus 1, x squared minus x plus 1. All right, that was nice. I think we should mark this with a star. 2. Let's quickly expand this. X plus 3. We saw 27 as 3 cubed. The first plus the second. The square of the first minus the product of the first, and the second plus the square of the second. Below, we have x squared minus 3x plus 9. These cancel out. Our answer is x plus 3. This wasn't very difficult. Let's expand this. There's a minus sign in between. For the first one, let's not put this in parentheses. First minus second. I'll distribute the minus in a moment. That's why I wrote it with parentheses. Times the square of the first, 2x minus 1 squared, plus the product of the first and the second, 2x minus 1 times x plus 2, plus the square of the second, x plus 2 squared. From 2x minus x, we get x. Minus 1 minus 2 makes minus 3. We're expanding this. 4x squared minus 4x plus 1. We're distributing these. Let me write one of them properly. I multiplied 2x by x. That's 2x squared. I multiplied 2x by 2, that's 4x. I multiplied minus 1 by x, that's minus x. I multiplied minus 1 by 2, that's minus 2. Now I'm expanding this. X squared plus 4x plus 4. Now 4x squared plus 2x squared is 6x squared plus 1 more x squared makes 7x squared. Minus 4x and plus 4x cancel each other out. 4x minus x is 3x, and 4 minus 2 is 2, plus 1 makes 3. And here we also have x minus 3. 7x squared plus 3x plus 3 can't be factored any further. This is our answer. Number 4. I think we should first expand this using the difference of squares. So this is the square of x cubed minus 2 to the 6th power. Let's see it as 8 squared. By the difference of squares, we get x cubed minus 8, x cubed plus 8. Now we see 8 as 2 cubed. We factor the first one as x minus 2 and x squared plus 2x plus 4. For the second one, x plus 2, when you're doing this, say it out loud if you can't solve it. X squared. Let's see if we get the same thing. It's not plus, of course. Minus 2x plus 4 units. And that's 4. That's our answer. For our fifth question, the numerator was 2x cubed minus 3y cubed. The denominator was 2x squared minus 3y squared. Let's expand it. The first is the difference of two cubes minus the second plus the square of the first plus the product of the first and second, which is 6xy plus the square of the second, which is 9y squared. Below, it's the difference of two squares, first minus second, first plus second. These terms cancel out completely, and our final answer is 4x squared plus 6xy plus 9y squared, all divided by 2x plus 3y. And that indeed is our complete answer. That was our fifth and final question for this session. Let's factorize our sixth question here. A plus b times a squared minus ab plus b squared. Here let's directly see a plus b in parentheses. Now let's factor out a plus b in parentheses as a common factor. In the first part, this remains. Plus, here, there's also a times 1 left. So, a squared minus a b plus b squared plus 1, that's all there is. We can't factor this any further. X cubed plus y cubed is 35 and x plus y is 5. It says, find xy for me. Let's factor this. X plus y times x squared minus xy plus y squared equals 35. If x plus y is 5, I substitute 5 here. 5 times x squared minus xy plus y squared equals 35. We divide both sides by 5. 7 left. So it's x squared minus xy plus y squared 7. Let's take this now. X plus y equals 5. Let's square both sides. Let's open this up. X squared plus 2xy plus y squared equals 25. Now if we find the sum of this and this, we're left with xy. That's what the question is asking us for. So let's isolate this. Let's leave x squared plus y squared on one side of the equation. I'm moving 2xy to the right side. 25 minus 2xy. I'm writing 25 minus 2xy instead of this. I wrote 25 minus 2xy instead of x squared plus y squared. Let's not forget there's a negative xy here. It equals 7. I moved the number 7 to the left. I left at 25. 18 equals minus 3xy. I moved it to the right. 3xy. From here, xy equals 6 if we divide both sides by 3. Let's add a little star to this one too. Number 8 is the difference of two cubes. First minus, since I'll distribute the negative, I opened a parenthesis. The second, the square of the first plus the product of the first, and the second plus the square of the second. When I distribute the negative, a minus cancels out. 2b remains. From here, 2b times, if we expand this, it's a squared plus 2ab plus b squared. Looks like there's a difference of two squares here. If you multiply a plus b and a minus b, you get a squared minus b squared. Here again, it's a squared minus 2ab plus b squared. This cancels out with that. Negative b squared cancels out with b squared. A squared, 3a squareds, and there's a b squared plus b squared. And at the front, there's 2b. So this is our answer. All right? Good. Number 9 says factor this. Shall we do it like this? Let's see it as x cubed minus 1. That is 1 cubed. So first minus second, then the square of the first. In other words, from x cubed squared, this, plus the product of the first and the second, x cubed plus the square of the second. So from 1 squared 1. All right? Now we can factor the first part. X minus 1, x squared plus x plus 1, like this. Can we do anything with this? Actually, if there are answer choices in the question, I think it's more important to look at them here, because it might have been left like this. But actually, it could also have been done like this. If we really want to do it, For example, if we absolutely have to factor x to the 6th plus x cubed just to make it easier, we can set x cubed as a. From here, we get a squared plus a plus 1. Later on, I'll do some more questions about this. We add plus a minus a here. This part becomes a squared plus 2a plus 1. And in the back, there's also a minus a. So it's the square of a plus 1 minus a. From here, it's the first minus the second. That is, the first minus the second. When we say the second, how do we see the minus a here? We see it as the square of the square root of a. This means therefore now we have a difference of two squares. First minus second. First plus second. Now what we called a was x cubed. So here it will be the square root of x cubed. If you ask me, they wouldn't put the choices like that. They would leave it like this in the options. But if there is something like x cubed under the square root or x times square root of x in the options, then of course we have to state that x is positive in order to take it out of the root. In that case, we can do the next step like this. I'm leaving it like this. Our 10th question. We did a similar question just now. If you haven't tried it, try this one. Let's open this up. A minus b. A squared plus ab plus b squared equals 63. A minus b is 3. So if this is 3 times, what makes 63? If we solve both sides, it's 21. So this part is 21. So a squared plus ab plus b squared equals 21. Now let's take this. A minus b was 3, so we square both sides. A squared minus 2ab plus b squared equals 9. Should I write it below? Let me write it. A squared minus 2ab plus b squared equals 9. If we subtract these from top to bottom, or if we multiply the bottom by a negative number, I'm distributing this negative number as it is. This is how it happens. Minus plus minus minus. I'm gathering them now. They're leaving. 3ab equals 12. So ab from there comes out to 4. Now, if we have 4 things here, we can do 2 things. First, even though the question doesn't say that the values of a and b are integers, since it will be easier, we first try 1 times 4, 2 times 2, and 4 times 1. If these don't work, we try the product of minus 1 and minus 4, minus 2 and minus 2, and minus 4 and minus 1. But on the other hand, to be able to find it, we'll also look at this. A minus b was 3, right? So if we move minus b to the other side, a equals b plus 3. Therefore, if we want, we can also find it by writing b plus 3 instead of a. But we can also think of it like this. The number a is 3 more than the number b. Look, the number a is 3 more than the number b. So let me also write down these alternatives where we factor with integers. One of these alternatives already worked. The number a is 3 more than b. All right, could it be this one? Negative 1 and negative 4. Yes, if b is negative 4, 3 more makes negative 1. This one also works. So here too, we found 2 alternatives. It could be 4 and 1. A is 4, b is 1. So a is 4 and b is 1, or a is negative 1 and b is negative 4. So is it this one or that one? Let's see. Now let's take this one. Let's move this negative b cubed to the right side. So a cubed equals b cubed plus 63. Does it work from here? B is negative 4, a is negative 1. When we put negative 1 for a, this becomes negative 1. When we put negative 4, it's negative 64 plus 63. Yes, negative 1 equals negative 1. So that's what happened. Let's check this one. A is 4, b is 1. 4 cubed equals, if we put 1 for b, 1 cubed plus 63. So from here, we also get 64 equals 64. Yes, it worked. It asks us to find the values of a and b. Therefore, a equals 4, b equals 1, or a equals negative 1, b equals negative 4. Both are possible, all right? That was our answer. There's no other issue, right? A is 4, b is negative 1, it's 3. Negative 1, negative 4, negative 1, negative... Yes, exactly. This was the 10th question. All right, let's go. See you in the next one. Let me repeat, you can join our school community from the description section, and you can download the clean solved PDFs of these and try solving them on your own. If you have any questions you want to ask me, or if you think it would be better if there were questions like these types, you can especially send me pictures of them through our school community. See you, take care.